Tonight, go outside and look up. Pick any star, anyone at all. It does not matter which. The bright one near the horizon, the faint cluster to the north, the one your grandfather pointed out to you when you were a child and told you the name of. Pick it. Look at it. Hold it in your eyes for a moment. Now here is what nobody told you about that star. You are not seeing it. What you are seeing is a photograph, a ghost. A message that left its source so long ago that the source itself may no longer exist. The light entering your eyes right now departed from that star hundreds, thousands, in some cases millions of years before you were born, before your parents were born, before your entire civilization existed. And while that light was traveling toward you across distances so vast that no human mind can genuinely hold them, the star that sent it was living out the rest of its life, burning through its fuel, expanding, collapsing, perhaps exploding in one of the most violent events the universe is capable of producing, perhaps shrinking into a cold, dark remnant that emits no light at all. You will never know. Because by the time you find out, you will have been dead for thousands of years. This is not a metaphor. It is not a poetic way of talking about memory or loss. It is a hard physical fact about the nature of light and distance and time that applies to every single point of light you have ever seen in the night sky. The universe does not show you what is happening. It shows you what happened. And the gap between those two things is measured not in seconds or years, but in the entire recorded history of human civilization multiplied many times over. To understand why, you need to understand something about light that feels simple, but carries consequences that will quietly rearrange the way you see everything. Light travels fast, faster than anything else in the universe. In a single second, light travels approximately 300,000 kilometers. That is roughly 7.5 times around the entire circumference of the Earth. In a single year, light travels about 9.46 trillion kilometers. We call that distance a light year, not a unit of time, a unit of distance. The distance light covers in 1 year, and here is where it starts to matter. The moon is about 1.3 light seconds away. When you look at the moon, you are seeing it as it was 1.3 seconds ago. That is almost nothing. The gap is so small, it is irrelevant for any practical purpose. The sun is about 8 light minutes away. When you look at the sun, and you should not directly, you are seeing it as it was 8 minutes ago. If the sun vanished right now, at this exact moment, you would not know for 8 minutes. You would continue to feel its warmth and see its light for 8 full minutes after it ceased to exist. That is strange. But it is still manageable. 8 minutes is a time frame a human can hold in mind. Then you step outside the solar system, and everything changes. The nearest star to our own sun is Proxima Centauri. It is approximately 4.2 light years away. When you look at Proxima Centauri, you are seeing it as it was 4.2 years ago. The light you are receiving tonight left that star when you were living a slightly different version of your life, when different things were happening in the world, when some people who are now gone were still alive. And Proxima Centauri is our nearest neighbor, the closest star other than the sun, the one right next door by cosmic standards. Now look further. Sirius, the brightest star in the night sky, is about 8.6 light years away. The light reaching your eyes from Sirius tonight left that star 8.6 years ago. Betelgeuse, the famous red supergiant in the constellation Orion, is approximately 700 light years away. When you look at Betelgeuse, you are seeing it as it was around the year 1325. The 100 Years' War had not yet begun. The Black Death was about to sweep across Europe. Chaucer had not yet written a single word of the Canterbury Tales. That is when the light you are looking at tonight left its source. And here's the thing about Betelgeuse that astronomers have known for decades, and that should make every stargazer pause. Betelgeuse is dying. It is a massive star at the end of its life, and at some point in the astronomical near future, which could mean anywhere from now to 100,000 years from now, it will go supernova. It will explode with such violence that for a period of weeks it may be visible in the daytime sky from Earth. It may briefly outshine the full moon at night. There is a genuine possibility, one that astronomers take seriously, that Betelgeuse has already exploded. that the supernova has already happened, that the shockwave is already moving toward us through space. But because Betelgeuse is 700 light years away, the light from that explosion has not reached us yet. We are still receiving the pre-explosion image of a star that may no longer exist in any form. We would not know until the light from the explosion arrived. And that news is currently traveling toward us at the speed of light, if it is traveling at all, and will arrive at a time we cannot predict. The astronomer Carl Sagan put it plainly in his series Cosmos. He wrote that when we look at the night sky, we are looking into the past. Not metaphorically, not poetically, literally. Each star is at a different distance and therefore at a different point in time. The night sky is not a flat canvas. It is a three-dimensional record of the past, with different stars showing us images from different historical eras, all arriving simultaneously at your retina on a Tuesday evening when you happen to glance up. Now push further still. The Andromeda Galaxy is the most distant object visible to the naked human eye. On a very dark, clear night, you can see it as a faint smudge of light in the constellation Andromeda. What you are seeing is the combined light of approximately 1 trillion stars, and that light left its source approximately 2.5 million years ago. The light currently entering your eye, photons actually landing on your retina, departed from those trillion stars when our ancestors were early members of the genus Homo, before Homo sapiens existed, before language, before fire was controlled, before any of the things that make us recognizably human had developed. 2.5 million years of travel, and it ends at your eye on a clear night if you know where to look. The cosmologist and author Brian Greene has described this quality of observation as looking back in time with every glance upward. It is not a limitation of our instruments. It is a fundamental feature of how light and distance work. There is no technology that can show you what a distant star looks like right now, because right now does not exist as a shared concept across the distances of space. By the time any information about a distant object reaches you, time has passed. The further away the object, the more time has passed. There are galaxies at the edge of the observable universe, detectable by our most powerful telescopes, whose light has been traveling for over 13 billion years. We are seeing those galaxies as they existed not long after the Big Bang. We have no idea what those regions of space look like today. We cannot know. The light from whatever they look like today will not reach us for billions of years. Some of it may never reach us at all, because the universe is expanding and the most distant regions are moving away from us faster than light can cross the gap. Let that sit for a moment. There are parts of the universe that we will never see, not because our telescopes are not powerful enough, but because the universe is expanding too fast for the light to ever reach us. There is a boundary, called the cosmic event horizon, beyond which events are permanently hidden from our view. Not temporarily, permanently. Whatever happens beyond that horizon is inaccessible to us forever, not due to any technological failure, but due to the fundamental geometry of an expanding universe. You live in a universe whose full contents are permanently, irreversibly invisible to you. And the portion you can see, the observable universe, you see only in its past states. The further you look, the further back in time you see. At the very edge of what we can observe, we are seeing the universe as it was in the first few 100 million years of its existence. We are looking at the early history of everything. This is what makes astronomy, at its deepest level, a form of time travel. Not the fictional kind where you step into a machine and arrive somewhere else. The real kind, where you step outside on a clear night, let your eyes adjust to the darkness, look up, and receive light that has been crossing the void for longer than your civilization has existed. Light that passed through interstellar space for centuries, for millennia, for millions of years with no destination in mind, and arrived by the sheerest accident of position at you. The physicist and author Richard Feynman once said that the beauty of science is that it does not subtract from wonder. It adds to it. Understanding how a flower works, he said, does not make it less beautiful. It makes it more so because you see layers of beauty that were invisible before. Tonight, when you go outside and look up, you will see the same sky you have always seen, the same stars in the same patterns, the same moon, the same planets tracing their slow paths. But you will also know, in a way you did not know before, that you are not seeing what is there. You are seeing what was there. A gallery of the past, arranged across the dome of the sky, each light a message from a different point in history, all arriving together at this single moment that you happen to occupy. You are standing at the receiving end of the longest messages ever sent, and none of the senders knew you were there.